Thank you. Thank you. I was the disciple of Ray Kurzweil last summer, and we are going to talk about a much more exciting subject, that is roads. So, for thousands of years, we built up an infrastructure based on roads for transporting people and for transporting goods from one place to another. And in Sweden, we like roads really much. We actually built 220,000 kilometers of road in Sweden. Paved road, that is. There is also a lot of dirt roads around, but 220,000 kilometers of road. Think about that for a second. And then think about the billion people in the world that don't have access to all-weathered, all-season roads. Because if you don't have access to roads, you don't have access to the economy. If you have a child and the child is sick, you can't take the child to hospital. If you have goods that you want to sell on the market, you can't take the goods to market. The roads is a fundamental part of the infrastructure that is needed. In sub-Saharan Africa, 85% of all the roads, mostly dirt roads that exist, gets flooded in the wet season, which means that a lot of people are cut off from communications. So what would it take to fix this problem? Roads are not cheap things. To build 1 meter of freeway costs roughly $5,000. And in order to build up a sufficient road network in the developing world to give everybody access to roads, annual investments of more than $34 billion are needed. And this is money that no one nation or constellation of nations can bring up. But let's look at some other aspects of roads. How many people here have sat waiting for a red light or waiting in a crossing? Yeah, quite some. Because actually the time spent waiting in cars in the US can be measured in billions of dollars and billions of hours. It's a productivity loss for society. And also, as you probably have read about a lot of cities worldwide that is heavily polluted. I visited Beijing in China a couple of years ago, and it was very clear that it wasn't very clear. You barely had vision 100, 200 meters, and that's largely because of the effects of using fossil fuels on the roads. So now when we have the opportunity to build a brand new infrastructure for an entire continent, is this really the solution that we want to implement? Or is there an alternative to roads? I believe there is a solution. And I believe in order to find this solution, we have to look up to the skies. When I was a kid, this technology was really expensive. But today, this technology, as Ray Kurzweil mentioned, has become cheap. And it's becoming cheaper and cheaper. At Singularity University this summer, we laid our hands on one of these things. This is a quadcopter. It's built from open source hardware, programmed with open source software, and it costs roughly $500 to buy all the parts needed for it. So we took this quadcopter and we figured, okay, so can we use this to solve the transportation issue? And this is just to give you a view of the software. That it's not only that the helicopters or the technology has become cheaper, but also the software has become more advanced. So this open source software makes it possible for flying vehicles to have automated takeoff and automated landing. And with a smartphone, you can program waypoints on the mission that you want this little vehicle to take on the way when it's out flying. So we twisted and turned this thing a couple of times. We changed the engines, we boosted the battery, and after a while, we had a prototype that could carry 2 kilograms over a distance of 10 kilometers. And this is just after a couple of weeks of hacking. Okay, with probably the best hackers in the world, but still, it's open source technology and open source software. So what can you use this for? 2 kilograms over 10 kilometers can, for example, be used in this setting. So at the top left corner, you have a hospital in a city, and in the lower right corner, you have a clinic in the field. And the baby is born in this clinic in a rural village. And what you do when the kid is born is that you need to get blood samples because you feel the doctor thinks that there might be something wrong with the kid. So you need to get verification from the hospital in town. So you need to get blood samples from the clinic to the hospital. You need to get the results back from the hospital, and you need to get vaccines or medicine back to the clinic. And today, this is often the solution used. So what do you do if the road is flooded? Or what do you do if the remote village is up in the mountains? With current transportation, it can take hours, even take days for the samples to come and go. And if you're the patient, this is probably not the scenario you were hoping for when you're out in the clinic. So why not use one of these instead? This is a prototype of an electronic unmanned aerial vehicle that can carry a load between the hospital and the clinic. You can call it a delivery pigeon to make it a little bit friendlier. The calculations we did showed that using one of these electronic devices for transportation is actually, even with the capital cost of the investment of the drone and the necessary ground stations and charging relays, is cheaper than sending a person on a motorbike. And also, since it's powered by electricity, and electricity in future, at least in Africa, will be solar powered. Otherwise, society has completely failed. So a little drone can travel across rivers. It can go above the mountains and reach the destination. And it goes a straight path. So how do we see this matter net unfolding? Well, we'll begin with launching pilots where we set up point-to-point transportations, like in the example that I just showed. And by setting up more point-to-point transportations and eventually connecting these, using the same principles as when the internet was founded. That you have little nodes, and then you have connections between the nodes, and the more nodes you have, the more sophisticated intelligence you need to coordinate the package distribution between the nodes. But since the advances in artificial intelligence is also going at a very rapid pace, we see that this is definitely possible. So this is our vision of the MatterNet, an internet for things. So in the same way, when you calculate on bandwidth, and you see that the bandwidth is increasing when you put in fiber cables or other cables for the internet, we see that the bandwidth in this case is how many kilos per kilometer we can transport. And also we have the price of kilometer per dollar, which means that how cheap is it to transport 1 kilo of mass over a distance of, for example, 10 kilometers. And as technology is exponentially making technology cheaper, we see that the price for transportation is also going to go down. And this is why we think that this idea of flying machines is not that far-fetched. even though it may seem like science fiction today. In short term, we're planning on launching these small 1 to 2 kilo packages. But within 5 to 10 years, we see that it's realistic to also ship heavier goods and even people. And this is what Ray Kurzweil thought about the idea. I'm actually going to read this. The developed world has a huge lead over the developing world in infrastructure. But our strategy should be to leapfrog these already obsolete and crumbling systems with 21st century solutions. That's what we did with phone systems, as developing societies went right to wireless and will never put in a wired landline system. Bits are already being widely distributed to emerging economies. Matternet will do that for atoms. When we presented this at the final ceremony, at the final week, it was picked up by a lot of speculating media around the world. There you can see the prototype of the drone where it's hovering. And we're launching our first pilot together with the Dominican Republic to be used for disaster relief in Haiti as a first pilot project, which is one first but very important step towards our vision of a roadless world. Thank you so much.